Hi, so what we have here now is a radical equation with two radicals in it. Okay, we have two square roots. This is going to start making things a little bit more complicated because we have to be careful on how we do the FOILing process. So what I've seen students do before, they can just go ahead and raise both sides of our equation to the second power. While that is legitimate, most students do mess up on the FOILing process on the left-hand side. So that's why I say it's legitimate, but it's not recommended. Okay, if you do want to see how that works, definitely come see me after class and I'll show you how much into the weeds you can get if you just go ahead and square both sides. But what I would recommend is whenever you want to get rid of the radicals, or whenever you have two square roots on both sides, move one of your radicals over to the other side of the equation. The reason why is because when you square both sides of your equation, it's so much easier to square one radical instead of squaring two radicals. Okay, it makes the FOILing process a whole lot easier. So what I'm going to do here, we're going to subtract the square root of x on both sides. So when we subtract the square root of x, well, on the left side, all we have left with is a square root of x plus 5 equals, on the right side, 5 minus the square root of x. All right. So now we can square both sides. We can raise both sides of our equation to the second power. Okie dokie. So now what we have on the left side, the square and the square root undo each other. They cancel each other out because they're inverses. So all we have left with on the left-hand side is x plus 5. And on the right side, yes, we are going to have to FOIL. But there's a couple of shortcuts you can use, but I do not recommend shortcuts when you're FOILing with radicals and square roots. What I would recommend, write it out in the two parentheses and actually draw out the FOILing method. So here we have a 5 minus the square root of x times 5 minus the square root of x. Okay, so this would be x plus 5 on the left-hand side. And when you FOIL, follow the arrows. 5 times 5, well, that gets you a 25. 5 times the negative square root of x, well, that gets you a minus 5 square root of x. Negative square root of x times 5 minus 5 square root of x. And then a negative square root of x times a negative square root of x. Well, I'm going to write it like this because I can show you what's going to happen in the step after that. It's a little bit of hindsight. But just remember, the negative times a negative, well, that gets you a positive. And square root of x times the square root of x, you could think of that as the square root of x squared. Okay? So now let's clean this up. That would be x plus 5 on the left-hand side. 25 now minus 5 square root of x minus 5 square root of x. Those are considered like terms. So we can just combine like terms by addition and subtraction. In this case, a negative 5 minus 5, well, that gets us a minus 10 square root of x. And then the square root of x squared, just remember, square and the square root undo each other. Okay, they unravel each other. So that just leaves us with plain old x. Now it's going to be a lot of crossing out, a lot of simplifying from here on out. So we can't really combine like terms on each side of the equal sign right now. But if we move stuff across the equal sign, now some things will cancel out. So let's subtract a 25 from both sides. Because remember, the bottom line, we're going to get that square root by itself. That's what we need to get. So if we take 5 minus 25, when we're combining like terms, we'd have an x minus 20 equals a negative 10 times the square root of x plus x on the right side. Here's something that's going to be interesting. In order to get that negative 10 squared of x by itself, we now have to subtract x on both sides. See, here's the cool part. The x's cancel out on each side of your equation. So that means we have a negative 20 equals a negative 10 times the square root of x. So we have to get the square root of x by itself. So now we can go ahead and divide both sides by negative 10. The negative 10s divide out on the right side. And then on the left side, negative 20 divided by negative 10, well, that gets us a positive 2 equals the square root of x. But hey, wait a second. We need x, not the square root of x. So how do we undo a square root? We square both sides. So if we square both sides of our equation, well, that means we have now 2 squared, well, that gets us a 4, and the square root of x squared, well, that gets us an x. So far we've got x equals 4. But what do we have to do once we get the answer? Always have to go back and check. Okay. So if we go ahead and plug in 4 in place of x, well, what we have here, okay, when we go ahead and check, the square root of 4 plus 5 plus the square root of 4, we hope it gives us 5. All right. So the square root of 4 plus 5, remember, we always have, in these particular problems, we're assuming the positive square root. So this would be the square root of 9 plus the square root of 4, hopefully gives us 5. Well, the square root of 9, the positive square root of 9, well, that gives us a 3. The positive square root of 4, well, that gives us a 2. We hope it equals 5. Well, hey, guess what? 3 plus 2 on the left-hand side actually does give us 5. So what that says, yeah, 5 equals 5. But what that means is that when we plug in 4 in for our x value, we end up with a true statement. So that verifies that when x is equal to 4, that solves our equation. So some notes you kind of want to be familiar with. Okay. Definitely the biggest thing, if you have trouble with it, definitely review your formulae techniques. And also, I guess if you think about it, you can also go ahead and review the your exponent rules. Okay, but the biggest thing here is your formulae techniques. A lot of students do struggle with formulae from time to time, especially when it deals with radicals. So, like I always say, if you have any questions, please don't be afraid to hit me up or anything along those lines. Happy to help outside of class. Until then, see you later.